Find the average rate of change. So first we have rate of change. So basically rate of change means G prime. So we're basically going to find the average, which is 1 over b minus a, of a to b, but we're doing G prime. Isn't that saying rate of change? And isn't this the average rate of change? So can we just simply do this? We want to find that. So, looking at, isn't this G prime right here? So we have is 1 over, well, isn't the interval from -3 to 7? So b is 7 minus -3, integral from -3 to 7, and G prime x dx. And that would end up being, well, 1 over 10. And isn't the area right here negative? Add up all these areas. All the areas are given. So wouldn't you add up all those? It'd be a -4 plus 1 1/2 minus 4 plus 1/2. If we do all that, we end up with -3 over 5. So that would be your average rate of change. Average rate of change. When you do all this, that's the area. That's G prime t from negative G prime x integrated from -3 to 7, and this is averaging it. For D, the average rate of change of G prime. So it's the same kind of question, except now we're doing the average of G double prime. Do we know G double prime? Do we know the area under G double prime? Because can we use the same steps? Not really. So if we want to find the average, we'll talk about this mean value theorem in a second, but if I want to do the average rate of change of G prime, well, isn't it saying rate of change? Isn't it saying the average slope of G prime? So if it's saying rate of change is slope of this, so could I take the slope, a nice perfectly straight line there. Don't I want to find that slope right there? Isn't this the rate of change from -3 to 7? Isn't that the slope? And is that the average slope? Yeah, it's the average slope over the whole interval. Now it's not very accurate, but it's the average slope for the whole interval. From starting to end, that's the somewhat average. It's not very good, but it's the average you can get. So could I just find that slope right there to solve the first part? So let's find that. If I want the average rate of change, that would be simply this is slope. So this coordinate would be, let's take this one to be a 1 minus -4 over 7 minus -3. Is that right? I took these coordinates, sorry, see these two coordinates? Find the slope of that line. This is the average slope of this. Again, this is G prime, so you find the average slope of it. So wouldn't that simply be, what, 5 over 10, which is 1/2? So that's your average slope, your average rate of change. If you take this whole graph, it's not very accurate. Anyways, okay, the second part of the question. Does the mean value theorem, NVT, applied the guarantee that there's a value in the interval which the second derivative is equal to the average rate of change? Why or why not? Now, what you got to do for mean value theorem is you got to go back to this idea. If you have 2 points and you have a slope right there, mean value theorem states somewhere between those 2 points there's another point with that slope. That's what mean value states. So if there's 2 points, the orange line, there's a graph somewhere between there, there's a slope that is same as that. So it's basically asking, this states, if mean value theorem applies, somewhere on this graph you have a slope of 1/2, guaranteed. Now, could you look at this for someone with a slope of 1/2? You probably have one right here, don't you? But can you guarantee it using mean value theorem? Now, there's two stipulations. The first stipulation for mean value theorem is it has to be continuous. And this is, which has to be continuous, we're talking about g prime x. Because isn't the g prime x the function we're using? So, is this graph continuous? Is it continuous? And it has to be continuous on the, oh, it's closed or open. It has to be continuous on the closed, yeah, closed. Is it continuous on the closed? Yes. The second stipulation, is it, but it's not differentiable. It is not differentiable on the open. Now, it has to be differentiable on the open interval and continuous on the closed. Why is it not differentiable? Does that have a derivative right there? These 3 points do not have derivatives. So since it's not differentiable on the whole interval, that is why you cannot guarantee it. No, not guaranteed, because g prime x not differentiable on interval. That would be your answer, because it's not on the interval differentiable.